we've gone to the trouble of defining and figuring out how to compute competitive equilibria. So why would we care about that? Do these allocations that we get from competitive equilibrium, are they even Pareto efficient? Well, for an allocation to be Pareto efficient, remember, at least on the interior of the Edgeworth box, we need that the marginal rates of substitution for the two consumers have to be equal to one another. Now, if the marginal rates of substitution have to be equal to one another, what happens in the competitive equilibrium? Well, in the competitive equilibrium, remember that the marginal rate of substitution when Rob picks his optimal bundle, he's going to set his marginal rate of substitution equal to minus PA over PB. And Friday's going to do the same thing. They're both going to set their marginal rate of substitution equal to exactly minus PA over PB. So since both of them set their marginal rates of substitution equal to minus PA over PB, their marginal rates of substitution are going to be equal. In other words, the allocation in equilibrium is going to be Pareto efficient. So let's look at an example. So the example that we did in the previous clip, the equilibrium allocation was this point right here. And the allocations, remember that this is a point where Rob has chosen his optimal bundle. So 34 apples and 21 and a quarter bananas is the optimal bundle for Rob. So all of the bundles that Rob thinks are better than this are in here. Right? They're above the indifference curve for Rob through that point, that equilibrium point. The bundles that Friday thinks are better are also above the indifference curve for Friday through that same point. Remember, his indifference curve is flipped over, right? So it's this one here. And so all the things that he thinks are better are down here. So what we see from this picture is that anything that Rob thinks is better than this equilibrium point, this equilibrium allocation, anything that Rob thinks is better is worse for Friday, and anything that Friday thinks is better, so any point here, so this would be an allocation that Friday thinks is better, but Rob is worse off. So we see then indeed that this equilibrium allocation is Pareto efficient. Okay, so this is a pretty robust result. It's generally going to be true, and it's called the first fundamental theorem of welfare economics. And it says that any competitive equilibrium allocation is Pareto efficient. It's one of the most important results in economics. Whenever you hear someone say markets are efficient, this is what they're referring to. So what it says is that there's no way to improve on the allocation that results in a competitive equilibrium in the sense of Pareto. In other words, there's no way to make both people better off than allowing them to trade and end up at a competitive equilibrium. So what this is that it's confirmation of this idea of the invisible hand. If Rob and Friday don't need to talk to each other, they can still end up at an efficient allocation just through the prices, just through this price adjustment process. Right? So just allowing the prices to adjust in a market is going to ensure that the resources are allocated efficiently. And that's what the first fundamental theorem tells us. Now, what we saw in this example was both consumers consuming on the interior of the Edgeworth box. And that's why their rates of substitution were equal to one another. Well, what if we're not on the interior of the Edgeworth box? What if we're on the corners or the edge of the Edgeworth box? Is this result still going to be true? The answer is yes. This is a very robust result. So take this picture, for example. So take this Edgeworth box. In this situation, the equilibrium allocation is G. At this allocation G, one of the two consumers, Friday, consumes positive amount of both goods. He consumes some apples, this many apples, and he consumes all of the bananas. Rob, on the other hand, he only consumes apples. He does not consume any bananas. So, can this still be a Pareto efficient allocation? Well, the answer is yes, because if we look at this situation, we look at the slopes of the indifference curves. Well, since Friday is consuming both goods, he is technically on the interior of his budget line. So he's going to have tangency of his indifference curve with the budget line. Right? So at this point G, his indifference curve has the same slope as the budget line. Rob's indifference curve, on the other hand, remember he's only consuming apples. So as we see in this picture, his indifference curve is steeper than the budget line. So since there is an area where we can make both of them better off, that has to be outside the edge width box. In other words, that involves allocations that are not feasible. So those are allocations here where Rob's consuming a negative number of apples, or sorry, a negative number of bananas. So there's no feasible allocation where both of them are better off. So indeed, this allocation G is Pareto efficient. So all that to say that the result that the competitive equilibrium is Pareto efficient doesn't rely on being on the interior. It's true even if the competitive equilibrium is on the boundaries of the Edgeworth box. Now we've looked so far at a very special type of economy where you have these traders who are endowed with some goods, and there's no production, there are no firms in these economies. What if we had a more complex economy where there were some consumers who and were endowed with some goods, who traded these goods, and maybe we also had some firms that produced things? Well, the first welfare theorem is going to hold even for such economies. What it's going to tell us is that the firms are going to produce an efficient mix of products, and that these products are going to be distributed or allocated among the consumers in an efficient way. So we're still going to end up with an efficient allocation of the resources. So the competitive equilibrium that's going to result, even when you have production, is going to be Pareto efficient. So it says that there's no way to produce or distribute goods in a way that makes everyone better off. In other words, central planning isn't really going to help. You can't do better by central planning than you can by just letting the market work. Now, there are some limitations to the first welfare theorem. The first is that you could have many competitive equilibria. The examples we worked through here, and for the most part, what you'll do in this course and probably in the next course, the situation will be where you have just one competitive equilibrium. And that's driven by the simplicity of the preferences that you've been working with. Now, all of these are going to be efficient, but what we don't know is if people just trade, which of the equilibria is going to rise. So the first welfare theorem doesn't tell us anything about that. Remember, the notion of Pareto efficiency also doesn't tell us anything about fairness or equity between the consumers, between people in the economy. And it's a pretty mild or a weak statement about the normative properties of an allocation. So Pareto efficiency is not saying a whole lot. And so the efficient allocation might not be fair or equitable in a reasonable way. So all the first welfare theorem is promising us is that the allocation is going to be Pareto efficient. But that doesn't tell us it's necessarily fair or just in a meaningful way. And so we need to, uh, those are additional uh, criteria that a social policy would need to take into account.